Chapter 2 was primarily about linear functions. We had some other kind of components inside of there as well, but our focus was primarily on lines. Our primary focus in Chapter 3 is going to be on quadratics. So these are quadratic functions and inequalities in section 3.1. So a general form for a quadratic is y equals ax squared plus bx plus c. If the a value is positive, you've got a parabola opening upward. If your a value is negative, your parabola opens downward. The vertex. So visually speaking, if this is my parabola, the vertex is this peak or this valley point, or if it's like this, it's this peak point. Those are the vertex. Can be found by taking these particular expressions. In particular, the first one, if you find negative b over 2a, calculate that. That will give you the x value of the vertex, and if you plug it back into the equation, you can get the y value of the vertex. And the vertex x value is exactly what's called the axis of symmetry. So let me actually, we're just going to have one of these on my screen so that I can reference it. This point is called the vertex. And if I were to put I'll do it like this, a line through that point, it would exactly cut my parabola in half, right? It makes it symmetric on the two sides of the dotted line. That's called the axis of symmetry. And obviously it occurs at the same x value as the vertex's x value occurs at, because they have the same point in common. Okay, good so far? I'm not going to switch the slide. It's fine. The first thing we're going to do in this section is identify these kinds of features of a parabola or of a quadratic function. We're going to identify the vertex. We're going to identify the axis of symmetry. We're going to decide, does it open up or does it open down? Okay? Okay, can I switch screens? Yeah? Some nods? Okay. Okay, so here's the parabola we're going to work with to start with. F of x equals negative 2x squared minus 8x plus 9. We're just finding the vertex. That's all it asks us to do. So we're going to find the x value. So it's supposed to say x equals negative b over 2a. Well, the b value is negative 8. So we have the opposite of negative 8 over 2 times that a value, which is negative 2. So I have 8 over negative 4, which gives me negative 2. So that's the x value of my vertex. To find the corresponding y value, I just plug it back into the equation. So the equation was negative 2 times my new x value that I just found, which is negative 2 squared, minus 8 times that x value, negative 2, plus 9. All right, so what is negative 2 squared? That one's 4 times the negative 2 in front would make it a negative 8, right? So I have negative 8, and then I have negative 8 times negative 2 in the middle, giving me a positive 16, and then positive 9 at the end. So either in your head, on your paper, in a calculator, what is negative 8 plus 16 minus 9, or plus 9? What do we get? 17? Okay. Is that right? Okay, so our vertex is an ordered pair. It's negative 2, 17. Okay? Do the same thing, new equation. Y equals negative x squared plus 2x minus 6. We're going to find the axis of symmetry in the vertex. We're also going to find some other pieces of information on this next slide, but we'll start here. So axis of symmetry, we've already done that once, so we'll have negative b. Let me write down x equals negative b over 2a. My b value is 2, so it's negative 2 over 2 times a, and a is actually negative 1. So negative 2 on top, negative 2 on bottom gives me 1. Okay, is that good? Mm-hmm. All right. Then we're going to plug that in to find the corresponding y value. So y is a negative, and then I have now a 1 squared plus 2 times 1 minus 6. So at the beginning, 1 squared is 1 times the negative makes it a negative 1. In the middle, 2 times 1 is 2. And at the end, I have my negative 6. What's my result? Negative 5. So my vertex is 1, negative 5. I guess I did part B. I'm sorry. My axis of symmetry I already have then as well because I just did it with the x value. I just should have stopped sooner. The axis of symmetry is the x value for the vertex, which was x equal 1. And then the vertex, I'll just shift it around, is 1, negative 5. There we go. It's all there. Okay, any questions on that? Let's identify a few other features for this graph as well. The x-intercept and the y-intercept in the other order that I just said them. We're going to identify its direction. We're going to graph it. We're going to identify where it's increasing, decrease, and then do the domain and range. We're going to do all the pieces. So some of these things we saw in our chapter 1 that we just, or chapter 2 that we just finished as well. All right, so our y-intercept, remember, is when x equals 0. That's what y-intercept is. So I just go through and I let x equal 0 and everything. So this is negative 0 squared minus 2 times 0 minus 6. What's that give me?
Negative 6.
Negative 6. So my y-intercept is the ordered pair 0, negative 6. Just shift this up a little bit so I'm out of space. Okay. Our x-intercept is when y equals 0. Now, that's generally a harder question to answer because if y is equal to 0, we have y on the left, and then on the right-hand side, I have a quadratic that has to be solved. Now, we have talked about how to solve quadratics. When we've worked with them, what we've had to do is either factor, or use a quadratic formula, or complete the square. Those are the 3 different things that we have done. And sometimes there are no x-intercepts when you're dealing with parabolas. So imagine, I'm just going to draw you sort of 3 pictures of what can happen. Good grief, what am I doing? Oh, I know what's going on. Okay. So with a graph, you can actually hit the x-axis twice, either if it opens up or down. You can hit the x-axis once where it's sort of bouncing off of it. That wasn't even a good attempt. That's better, right? It just kind of bounces off of it. Or it could be like straight up, like I drew it accidentally a minute ago, where it's hovering above and it doesn't have any x-intercepts. All 3 of those are possibilities. So usually what I would recommend is try to factor it and see if it factors. On this one, it's not especially friendly that the x squared's negative. So you could either factor out a negative or you could just divide it by a negative, everything. So if you divide everything by a negative, you would end up getting 0 equals x squared minus 2x and plus 6. It's easier to work with if you're trying to factor, for you to have a coefficient in front of the x squared that's positive. So I'm going to spoil all the fun and just tell you right now, this one won't factor. They're very friendly when they do factor, but this one just doesn't. If we attempt to try to find two numbers that multiply to 6, I can't get them to add to -2. It's not possible. So this one's not going to factor. So our second sort of line of, options would probably be to do quadratic formula. So that's where we're going to head to next. So I have no space. So I'm going to shift this up, cut that out, and shift this up. So if I'm doing quadratic formula, this is x equals, and I can use either the original equation or the one that I changed. It doesn't matter. Your pick. If you change all the signs and you change none of the signs, you get the same answers. So your pick. I've just already changed my signs and I've got fewer negatives, so I'm going to go with that. So x equals -b, so opposite of -2, plus or minus the square root of b squared, which is -2 squared, minus 4 times a, which is 1, times c, which is 6, over 2 times a, which is 1. Again, change all your signs, use the original one if you wish. It won't give you any different answer. There's a little bit of process different in the middle of it, but it's the same answer. So what I'd like for you to do is just to calculate the discriminant. Discriminant, remember, is the part that's underneath the radical. So if you just find out what is -2 squared minus 4 times 1 times 6, what will you get underneath the radical?
-20.
-20. And in particular, the part that matters about that answer you just gave me is that it is negative. So it means I get imaginary numbers, right? And we will talk more about imaginary numbers in a later chapter, but we're not working with imaginary numbers right now because we're working on a real number line, right? The coordinate axis, xy axis, is with the real numbers. So the fact is that because I got an imaginary number underneath the radical, my image actually looks like that last one that I drew up here. Whoa. It looks something like this, where it's not going to cross the x-axis. That's why I'm getting imaginary answers when I do my quadratic formula. So what does that mean? And it's not going to look like that because it's going to be flipped upside down. It's going to look more like this, something. But it's not going to cross the x-axis is the point. So this is that there are no x-intercepts. And the fact that none exist is definitely an answer option. Sometimes it feels like that shouldn't be an answer option, but it is. It's definitely a possibility. How does this graph open? I've already spoiled the fun on that one too. I told you it opened down. Why do I know it opens down? Yeah, there's actually a negative in front of my x squared term, right? In the original equation I was given. That tells me it opens down. So we do in fact have a graph opening downward. Now this says graph it. I've sort of sketched this random graph in the air, but I have enough details to give a much more accurate sketch as well. Over here it says my axis of symmetry is at x equal 1. So I'm going to draw a dotted line in at x equal 1. That's going to cut my parabola in half. And I know it's opening downward. I also have a vertex. It's 1, -5. So here's 1, 2, 3, 4, and 5. That's my vertex, and then it needs to open downward, like this, roughly speaking. But I can get a little more precise because I also know the y-intercept. It's at -6. So at -6, I need to cross the axis over here. Okay, it doesn't look very symmetric, but you know it is in theory, right? Sure.
Vertex is the vertex, it's 1, -5, right?
Mm-hmm. Okay, so a few more features about this graph. It asks us for where it's increasing, decreasing, and what the domain and the range are. So let's do the increasing, decreasing one first. Where is this graph increasing? Right. So it's increasing over here, visually speaking, right, Bailey? The part I've highlighted in yellow. And we read the graph from left to right. If we start at the far left, that's -infinity x values, and we stop at the x value of 1. Whoops, that's not what I meant to hit. I meant to that. Okay, So my increasing value is that it's going from negative infinity to 1. And again, I told you that I don't care whether you use parentheses or brackets. Just from the looks of my notes, I'm pretty sure your book's using brackets and probably my math lab as well. So just be aware of that. But if you use parentheses on increasing, decreasing, it's fine. Where's the graph decreasing? It's after, yeah, 1 to infinity, you're right. So again, we're reading from left to right. We start at that vertex and then we move to the right-hand side. The vertex x value is 1. And if I'm moving to the right, I'm going to continue moving to the right forever or indefinitely. That's an infinity value. Okay, so domain and range. Domain means x values I'm allowed to have. So if I'm walking from left to right along the x-axis, what values do I have? Yeah, all real numbers, negative infinity to infinity. Range y values, I'm climbing up the y-axis.
Negative 5 to...
Negative infinity first, so always start with the smallest value, and where does it stop? That one stops at negative 5. Here it matters that you do a bracket, and a parenthesis will not suffice, because it actually equals negative 5 for real. Like I actually have a y value of negative 5. Kenny?
Because we
Can you
calculate
explain how you graphed everything?
Yes, I plotted the points I found. Like I started by plotting the axis of symmetry was part A, so I graphed x equal 1. I plotted the vertex from part B, 1, negative 5. And I plotted over here the y-intercept from part C at 0, negative 6. And then I used the fact that I knew that it was opening downward to connect my dots. And it always will have the shape of a parabola, so you have a lot to go on at that point, enough to do a picture. Yeah. All right.
This is kind of off topic, but do you have a dog?
I do have a dog, yes.
What kind of dog is it?
She's a lab mix. All right, standard form. There is another standard form that we can use for a parabola. And it's actually very friendly, visually speaking, because it allows me to find like the vertex without doing any work, which is great.
Yes,
Yeah,
that
that's
is
good
what
stuff.
we want.
So it looks like this. Y equals A times x minus h squared plus k. The A value, which by the way, A stands for amplitude. I didn't say that before, but that's what A stands for, is amplitude. The A value, the amplitude being positive means it opens up. Amplitude negative means it opens down. That's the statement we had before. None of that changed. But the nice thing about this particular form, if you already have it especially, is that the vertex is already visibly there. The vertex is h, which is the value in the middle, but the opposite sign. Notice that's different. And k, value at the end, but it's the same sign. And then the axis of symmetry still lines up with what the vertex is. So since the axis of symmetry, or the vertex x value is h, the axis of symmetry will be x equal h. So like I said, it's really nice if it's already given in this form. But we can also take an equation and put it into this form. And I'd like to show you how to do that. So the first thing we're going to do is we're going to actually take an equation that's not in this form and sort of see how we can put it into this form. I don't know that it's necessarily any more or less work than finding the vertex over here like we did. So it's not like, oh my goodness, this is a more complicated process. It's really not. It's about the same in terms of numbers of steps and complication. It's just a different way of doing it. So the equation we're going to look at to start with is y equal x squared minus 6x plus 10. And we have done the equivalent of this before. We just didn't do it for this purpose. So what we're going to do first is we're going to sort of isolate x squared minus 6x, and we're going to leave a blank space and put the 10 on the outside. So we're grouping them together with a space next to them. We did this when we found the center of a circle. That's when we saw this before.
Oh my gosh.
The process is called completing the square. Okay, Okay? So the key to completing the square is b divided by 2 squared. So my b value here is negative 6. So negative 6 divided by 2 is negative 3, and negative 3 squared is positive 9. And when we did this for completing the square for finding the center of a circle, we said if I add 9 to this side, I have to add 9 to the other side. Y'all remember that? Okay. And that's true. I could write plus 9 on the other side with y. That would be okay. But I really don't want anything on the other side with y. Right? I mean, that's not where I want values to actually end up. So instead of adding 9 to the other side, I'm just going to subtract 9 from the same side. Right? You guys do this with time management all the time. If I add time on Facebook, I have to take away time on Twitter or whatever. Right? You only have so much time. So you're adding and subtracting all the time. So it's the same thing here. Okay, so as we take a look at this piece that's in parentheses will always factor as a perfect square. That's why the completing the square matters. So if you'll remember, the way that that works is that it takes the first piece without the squaring part. It takes the last piece, its square root, which would be 3, and it takes the sign for what's in the middle. And then we square it.
Plus 1.
Always has that beautiful form. And then, yes, we will have plus 1 on the outside.
Yay.
The 10 and the negative 9.
Wait, what did plus 1 come? Oh, 10 minus 9.
Yep.
Came from outer space.
Now, let's be honest. This one was actually very friendly because the numbers divided so nicely and they were beautiful, and it doesn't always work out that way. Right? It doesn't. However, I would speculate that more times than not, the problems that you're going to be given are going to be nice ones. That's how people generate the problems they put in textbooks, right? Y'all know that. Yeah? Real life doesn't give you such nice values sometimes. So probably more often than not, you're going to see things that are going to work out very nicely. All right, so let's actually take one that's already given to you in standard form that looks like that and do all the same pieces of information. That's all we were asked to do here, didn't it? Did it? Oh, it did ask us to find the vertex. You're right. I'm so sorry. Maxwell, you want to help me find the vertex?
It's going to be positive 3 and 1.
Yes, it is. Good. Okay, so remember the sign is the opposite from the middle part. So it's positive 3. It's the same as the ending part. Okay, so do you want to know why it actually happens?
Why?
We talked about transformations in the previous section of material, right? Chapter 2. We talked about everything that happens on the inside moves things the opposite direction. So that negative 3 moves it right 3, which means I'm now going to be at positive 3. God? I'm pretty sure God came up with it. Mathematics was discovered, not created. All right. Problem 4. We were actually given one already in standard form, and it's beautiful because we don't have to do much work. I mean, that's really what it means. So you're given a problem like this, say thank you to God because this is a beautiful problem to be given, all right? All right, so axis of symmetry. What is the axis of symmetry for this equation? Okay, so you're giving me the vertex, Kenny. Let me actually fill it in, though. You're right. The vertex is -1, -9. That's true. And then once you know the vertex, the axis of symmetry is always a line that is x equals the x value of the vertex. In this case, -1. They always match. Okay, so the bad news is y-intercepts and x-intercepts are found a little bit differently because it's in standard form like this, right? They aren't different. It's just the process looks a little bit different. So your y-intercept, again, is when x equals 0. So we would have y equals 0 plus 1 squared minus 9. So 0 plus 1 is? 1 squared is?
1.
Minus 9 is?
-8.
-8. So my y-intercept is 0, -8. Okay? Y-intercept x equals 0. x-intercept, we let y equal 0. So this is now 0 equals x plus 1 squared minus 9. Okay. There's lots of things you could do.
We're gonna have to FOIL.
Nope. One option is that you could multiply it all out, attempt to factor it, attempt to do quadratic formula. That's an option. That's not your simplest option. Bailey, you're trying to tell me what to do. What would you like me to do?
Square it all.
Okay, we are going to take a square root, which I think is what you meant. But before we do that, we need to do something else. We're going to add the 9 to the other side. Yeah. So we saw this happen in intermediate algebra. It was the square root principle. We said, okay, well, if we could get something so that it was actually written as something squared, that'd be very nice. Well, we have that. My x plus 1 is written as something squared. And in fact, it does equal 9. And then Bailey is exactly right. We're going to take a square root. But what do we need to remember whenever we take a square root?
Plus or minus.
Plus or minus. So the square root of 9 is
Plus or minus 3.
plus or minus 3. So there's really two options here. One option is that x plus 1 equals 3. The other option is that x plus 1 equals negative 3. We get two different answers. Don't just think you're going to move the 1 and now you're going to get plus or minus the same value. You're not. You're going to get two distinctly different answers. So when I subtract the 1 here, what does x equal? 2. Good. And over here, if I subtract my 1, what does x equal? Yep, negative 4. So those are my two x-intercepts. So this time it doesn't not cross the x-intercept or x-axis like the last one. It actually crosses it twice. So my x-intercepts, which took way too much space on this, I'm just going to shift it over for a moment because I know some of you are still writing it down. We'll delete it in a second. But my x-intercepts are at 2, 0, and negative 4, 0. How does this graph open?
Yeah.
How'd you know, Bailey? Because it's a little bit hidden on this one.
I don't know. Because like where the parentheses are, it's positive.
Yeah. Right in front of here is where we'd be looking for an a value. There's nothing written there, so it's an understood 1, and that would be an understood positive 1. Yeah, you're right. So we actually have it opening up. We're going to graph it next. So all my work for finding my x-intercept, are you guys okay if I delete that at this point? Normally don't like to delete things, but I definitely have run out of space. Okay, so we're going to plot all the pieces that we have found so far, and we're just going to go in order. It says my axis of symmetry is x equal negative 1, so that would be over here. My vertex is at negative 1, negative 9, so that's pretty far down. That's about right. Negative 1, negative 9. My y-intercept is at 0, negative 8. And have two x-intercepts, 2, 0, and negative 4, 0. So those are all the pieces that I found so far. And if I throw in there the fact that I know that it's opening upward, and the shape is a basic U shape because it's a parabola, right? The graph looks something like that. Okay. Increasing, decreasing. It does take up a lot of space, I know. All right, so increasing first, just because it's in order. Where is this graph increasing? Negative 1 to infinity, right? Because it's halfway through it that it's increasing, right? On the right-hand side. Where is it decreasing? From the left-hand side, right? So it's decreasing from, remember we have to read the graph from left to right. It's like we're driving. I realize the hill goes up both directions, but you can't both look forward and backward at the same time. So we're always going to read from left to right. So it starts decreasing on the far left, and it stops decreasing in the middle. In this case, that middle is at negative 1. Okay, any questions on that?
Are we not going to go to the nine?
It didn't ask it for us on this one. It could, but it just didn't on this one. Okay, so we're going to do a little bit more practice with that completing the square process, because I told you they don't always work out quite so beautifully, and I want you to have an anticipation of what do I do if they don't work out that nicely, but the question still asked me to do it. What do I do? So the next two examples are doing just that. They're going to be giving you functions that are not quite so easy to put in standard form using completing the square. The process is still the same. We separate the pieces that have x with them away from the one that doesn't. The problem is that negative b over 2a does not end up being a whole number here. It's okay. We'll promise we'll deal with it together. What I didn't mean 2a. Negative b over 2 squared is what I meant to say. Sorry. That was my Vertex formula. That's what I meant to write. Okay. What is negative b? B is 1, right? I'm sorry, is negative 1. So this is the opposite of negative 1. So I have 1.
B squared, b over 2 squared, not negative b.
Oh, it doesn't matter. You're right, it is. But you square things, so it doesn't matter. You're right. I'm sorry. Got that negative in there for my Vertex formula, and I forgot to remove it. Okay, so what is 1 over 2? It's 1/2, right? I don't have a whole number like I did last time. What is 1/2 squared? 1/4. Okay, so I know you're anticipating ugly, awful things, and it's not as bad as you think it's going to be. Okay, so here's what we're going to do. We're going to put that 1/4 right here, and we're going to compensate by subtracting a 1/4 out here. Everybody good so far? Here's where it's very nice and friendly that this middle part always factors in a specific way. This is always x. This is always the same sign. And this piece is always the square root. So what is the square root of 1/4? It's 1/2. Right? It's the value I actually had over here before I did the dividing, or before I did the squaring. All right? So I have that squared on the outside. Don't forget that piece. That's important. What is positive 1 and negative 1/4?
Subtracted from each other, 0.75.
0.75, or as a fraction, it would be 3 over 4. You can use decimals if you wish. Just make the decision in the problem to use all decimals or all fractions. Don't intermix them. And we're done. That's the completing the square formula. Now we're going to find the vertex still, but that's the completed square. Like that, we're done with the actual calculation process. What is the vertex then based on this form?
1/2, 3/4.
1/2, 3/4. Yes, indeed. Okay. How is part B different?
There's the number in front of you.
There is a number in front of the x squared. And that actually makes it be treated, that's really bad English, it makes it be treated really different. We will treat it very differently because of that. Let me show you what we will do. While we will group together the pieces that have the x's in them, we need that 3 to be on the outside of the parenthesis. So we're going to factor a 3 out. That gives me x squared minus 4x inside, leave a space, and I've got my 1 on the outside. So I'm only factoring the 3 out of the pieces that have the x squareds in them, okay? The place where I have the space, I will find my value just like I did before. B over 2 squared. And the b value now that I'm working with is in fact negative 4. So negative 4 divided by 2 is negative 2, and then negative 2 squared is 4. Now, don't get too carried away. There is a positive 4 that I put where the space is, but I do not put a negative 4 on the outside. I will put a negative 12. Any idea why? Yeah, this new value of 4 that I just put in here, whoops, I didn't mean to do that, is still also multiplied by the 3 that's on the outside. I didn't really add 4 to my equation. I really added 4 times the 3 on the outside. I added 12. So I have to compensate by subtracting the 12 on the end. It's a nuance, right? It's something that's slightly different. It's not something you guys can't handle. It's just something to be aware of, that it's treated a little bit differently. Now, all of the factoring, everything else after that works very much the same way, right? This piece is square rooted. This piece keeps the sign, and this piece is square rooted for a 2. Square on the outside. Oops, and then I have 1 and negative 12, making it a negative 11. So this one has an a value that's 3 instead of 1, right? The one we just did before had an a value of 1. Most of them that we've done have had an a value of 1, actually. All it does is it makes the parabola skinny. Because what it really does is it makes it vertically stretched up. Remember those translations we did?
The graph went on Weight
Yeah.
Watchers.
The graph went on Weight Watchers. And got taller.
Oh my gosh.
Right? Can you imagine if we took us and we just stretched us up, but we still had the same amount of weight, we'd just be taller
Oh, that
too?
would be
Be like
nice.
that. Okay, so what is my vertex?
Positive 2,
+2
negative 11.
and -11. So the vertex is still found in exactly the same way. Okay, there's one more piece of information that we're going to take a look at today. The title of our section said Quadratic Equations and Inequalities. It's the inequalities section that we still have to work through. This is solving quadratic inequalities. There are other methods for doing that. The one that we're going to present consistent with your book and so forth is called the test point method. And it looks something like this. First, we move everything to the same side, which is what we would do for an equation. The second thing is that we factor the side that doesn't have 0 on it, which we would do for an equation. And then we would put those values on a number line. That's different. What that does is it creates 3 separate intervals. So visually speaking, at some point you have 2 values that you found. We'll call them A and B. So we have the space here, we have space here, and we have space here. There's 3 different intervals of values that we have to consider. So these are the intervals it references down here. We check those intervals using test points, hence the test point method. And then we will state our solution.
Check intervals.
Okay, here's an inequality for us to look at. X squared plus x is greater than or equal to 2. Just like it said, if it said equals, we would first move everything to the other side, to the same side. So it will say x squared plus x minus 2 greater than or equal to 0. Is that okay? Just moved the values to the same side. Second step is to factor. Okay, so I have x and I have x. As long as it factors, sometimes they won't factor. I've got an example of that too, but I need the signs to be opposite of each other so that I can get a negative 2 at the end. And I want this to be a 2 and a 1 to give me a 2. The 2 needs to be positive, the 1 needs to be negative, so that when I look at my inside and my outsides, I end up with getting a positive x in the middle. So that's what my factoring would look like. Next, we set each factor equal to 0. So far I have absolutely done nothing related to that inequality. So if I add my 1, this is x equal 1, subtract my 2, x equal -2. Okay, everybody good so far? That's nothing new. We've been doing that. This is the part that's new. We make an interval, oops, I didn't mean an interval, a line, like a number line, and we put the numbers on them. We put on in order, right? -2 comes before 1, so it looks like that. And then we pick test points. So your points and my points don't have to match because I don't really care what number I get. So maybe you pick -3 here. Maybe you pick a 0 in between, and maybe you pick a 2 on the right. Maybe you don't. But you have to pick number between the values they give you, like in those places. And then what you do is you put them into your inequality. And what you're wanting to do, not even that, but this piece right here. What you want to know is, do I get a positive number or do I get a negative number? So for instance, if I put in -3, if I do -3 squared plus -3 minus 2, well, -3 squared is 9. 9 minus 3 minus 2, I get a positive, right? That's what matters. If I put in a 0, you can probably see very quickly what happens with 0, right? Yeah, these two just cancel, so you get a negative. And then we'll try the +2. So 2 squared, what was it? Plus 2 minus 2. That's positive as well. So why am I looking for positives and negatives? Well, the reason I'm doing that is because it tells me to. It tells me I want values that are greater than or equal to 0. So do I want positives or do I want negatives? I want positives on this one. These are the values that are my answer. So values that come before -2, which would be -infinity to -2. It can equal 0, so I get to equal 2. That's what this equal sign here tells me. And then I do a union, and then I have from 1 to infinity. This is my interval of values that satisfy this inequality. All right, I have one more example. I'm going to let you go, and I will record that one example and post it. I'm going to post it as a separate video so that I can go ahead and get this uploaded. It's probably only going to be like 2 or 3 minutes, but it shows you what happens when it doesn't factor. It's the same thing except for I end up with something that doesn't factor, and I need you to see what happens because it looks a little different. Have a great day, guys.